Good morning, everyone. Welcome back to the online classes of Design of Steel and Masonry Structures. So, last class we have studied about classification of dam, that is rigid dam and non-rigid dam, and also the gravity dams, which is included for your syllabus. So, today's class we will deal with elementary profile of a masonry dam. So, last class we have studied that the gravity dams which are designed. So the basic profile of the gravity dam is triangular in shape, but as per the practical purpose, the dams are designed in trapezoidal shape. So today we will study the elementary profile of a masonry dam or gravity dam. Okay, so considering practical purpose, the elementary profile of a gravity dam or a masonry dam is trapezoidal in shape. So trapezoidal in shape means I will explain you the details. So let's consider a trapezoidal dam. So let this be the top width, that is A. A is considered as the top width of the dam. B, the bottom width of the dam, and capital H, that is total height of the dam. Small h, that is the height of the water stored in the dam, and let this point be the CG, where the entire mass of the dam is concentrated to be acting, okay, center of gravity. So P is the water pressure, which is the external pressure acting on the body wall of the dam. W is nothing but the self weight of the dam. R is the resultant, and the other points is x bar, that is the distance from the water phase to the center of gravity, and Z. So Z, it should always be, so Z means it is the distance from the heel to the point where the resultant acts. Okay, so heel and toe, as we have the feet, we will see we will having toe at the front side and heel at the back side. So here also in the dam, so the back point, that is where we are storing the water, that is called as the heel. So this point A is called as the heel of the dam, and point B, the front point, is called as a toe of the dam. Okay, so Z is nothing but it is the distance from the heel of the dam to the point where the resultant will be acting. Okay, so always remember, so this resultant, it should be within the body of the dam, it should be acting within the body of the dam, that is Z should be equal to B by 6, base divided by 6. It should not be outside the body of the dam. If this resultant will be acting outside of the body of the dam, then the dam will be leading to failure. Okay, so this R is nothing but the resultant. Okay, so one by one I will explain you the salient features of the dam. So A is nothing but the top width of the dam. B, the bottom width of the dam, and capital H is the total height of the dam. This capital H, it is nothing but the total height of the dam. And small h means the height of the water stored in the dam, to what extent we are storing the water, that is called as a small h. Okay, and W is nothing but the self weight of the dam per unit length. Okay, and R is the resultant. P is the water pressure. CG is nothing but the center of gravity. E is eccentricity, this E is the eccentricity, and rho means a specific weight of masonry, the specific weight of the masonry. If it is masonry, the specific weight will be different. If it is concrete, again the specific weight will be different. And Z means the distance between heel of the dam point A to the point where the resultant cuts the base. So Z means this Z, it is the distance from the heel of the dam, that is point A, to the point where the resultant cuts at the base, that is called as a Z. Okay, so these are the basic salient features of elementary profile of the dam. So the next topic is external forces acting on the gravity dam. Okay, so after studying the elementary profile of the dam, we will deal with the topic that is external forces acting on the gravity dam. So when we are constructing the dam, there will be several forces acting on the dam. So these external forces, okay, these are classified as the number one is water pressure, second one uplift pressure, third one earthquake pressure, fourth silt pressure, fifth self weight of the dam, sixth wave pressure, seventh wind pressure, eighth one is ice pressure. Okay, so one by one we will deal with the different types of pressures acting on the dam. So for your external exam, the question may be asked as list the different external forces acting on the dam. It will be for 5 marks. So you have to list one by one. Okay, so the various external forces acting on gravity dam are as water pressure, uplift pressure, earthquake pressure, silt pressure, self weight of the dam, wave pressure, wind pressure and ice pressure. So one by one in brief I will explain you the things. So the number one is water pressure. So to explain these different pressures, I will take help of a diagram. That is, so here I have drawn a diagram. Okay, so through this diagram, one by one we will study the different types of external forces acting on the dam. Okay, so if this is a gravity dam or a masonry dam, okay, so in this what will happen? This width is called as top width, that is designated as small a, and this is called as bottom width, which is designated as small b. Okay, and this capital H, so capital H, it is nothing but the total height of the dam from bottom to the top. Okay, and this small h is, it is the total height of the water which is stored in the dam. So as we have studied in irrigation bridge drawing, total height will be different and maximum water level, that will be different. So here this small h is nothing but it is same as the maximum water level, that is the maximum height to which the water can be stored in the dam. Okay, so what happens when we are storing the water in the dam? Okay, when we are storing water in the dam, what happens? This quantity of water, that is small h height of the water, will be exerting some kind of pressure on the body wall of the dam. Okay, so this pressure is called as a water pressure. Okay, so this pressure, whatever the water will be exerting the pressure on the body wall of the dam, this is called as water pressure. That is the number one external force. So this external force is the major force which leads into failure of the dam. Hence the dam should be properly designed to resist this water pressure. Okay, the second one is uplift pressure. Uplift pressure means, so no structures are watertight. Whatever structures are designed, they are not 100% watertight. Okay, so water, it is a liquid which has the tendency to flow. Water, it finds a slight slope also, the water starts flowing. Okay, so when we are storing the water here, so this area is called as a reservoir and this part is called as dam. So when we construct the dam, behind the dam there will be a reservoir. Okay, so the bed of the reservoir will be of earth, that is nothing but soil. There will be no concrete or nothing. Okay, so what happens when we store the water here? So this water, what happens? Through this soil, it starts percolating through the bottom of the dam. Okay, so as we are having the foundation of the dam, what happens? This water will tend to uplift the heel of the dam. Okay, so this is called as uplift pressure. So the self weight should be sufficient that it should resist this uplift pressure. Okay, so this water, whatever it starts flowing through the bottom of the dam, this is called as uplift pressure. And the third one is earthquake pressure. So earthquake pressure means the pressure which is caused due to earthquakes. Okay, if we are constructing the dams in seismic zones, seismic zone means the areas which are prone to earthquakes, where maximum earthquakes will be occurring. So in such places, what we have to do? We have to consider the pressure or forces caused due to earthquakes. And the fourth one is silt pressure. So silt pressure means, so whenever rainfall occurs, whenever there will be floods, what will happen? The rivers will be overflowing. Okay, there will be flood like situation. So what happens? The water from the river and the streams, what they will do? They will join the reservoir basin. So when the river water or the stream water starts flowing, it will carry different types of particles. Okay, so the insoluble particles such as leaf, papers, etc., what they will do? They will settle at some other places. But the fine particles, that is nothing but the soil, fine earth which is mixed with the soil, it will flow along with the water. So this is called as silt. The fine powder which comes along with the water is called as silt. So we should see that the silt is avoided to enter into the reservoir basin. So what happens when the river water enters into the reservoir basin? It carries fine soil particles that is called as silt. This silt starts depositing in the base of the dam. Okay, so when it starts depositing at the base of the dam, what will happen? The quantity of water stored gradually decreases and this silt amount increases. So as the silt increases, this silt will tend to act some external force that is called as a silt pressure. Okay, and the next one is a self weight of the dam. Self weight of the dam means the entire weight of the dam. If we are constructing by masonry, the weight will be different. If we are constructing by concrete, the weight will be different. If we are constructing the dam by using steel, the weight will be different. So this self weight of the dam is the major force which resists all the external forces which are acting on the dam. Okay, and the next one is wave pressure. Wave pressure means, so you might have seen when we are storing the water to the maximum height, what happens? Due to the heavy wind, okay, dam will be having, it will be of greater height. So dam will be of greater height. So as the height increases, what will happen? The wind velocity will also be increased. So when we are storing the water to the maximum height, due to the heavy wind velocity, there will be generation of waves at the surface of the water. Okay, so on the surface of the water, there will be wave generation. So these waves, what will happen when the heavy wind flows, the waves will tend some force on the face of the dam. So this is called as wave pressure. Okay, wind pressure. Wind pressure. The next one is wind pressure. Wind pressure means, so as I told, the height of the dam will be too large. Okay, so when the height of the dam is very large, so as the height increases, the velocity of wind also increases. Okay, so you might have seen, for example, if I tell you, so if a structure is constructed for ground floor, the velocity of the wind will be less. If we construct for first floor, the velocity of wind will slightly increase. Again, if we go for second floor, the velocity of wind will be slightly, again it will be increased. So as the height of the structure increases, the velocity of the wind also increases. So as the height of the dam is very large, so we have to consider the wind also. So wind will be exerting slight amount of pressure, that is called as wind pressure. And the last one is ice pressure. So ice pressure means, if we are constructing the dams in colder regions, okay, so for example in the areas where snowfall is very large, okay, so example, if I tell you, if you go for Jammu and Kashmir, if you go for Uttarakhand, so there if we are constructing dams, so what will happen? During winter season, the water will be turned into ice. Okay, the water, it will convert it because of a dense or because of cold climate, the water will turn itself into ice. So in those places, what will happen? We have to consider ice pressure also, because the volume of the water is different and the volume of the ice is different. So in designing of the dam, when we are constructing the dam in colder regions, we have to consider the one more pressure, that is called as ice pressure.